This lesson is on section 1.6, relations and functions. Relations are sets of ordered pairs. The inputs are the x-coordinates, comprising the domain. The outputs are the y-coordinates, comprising the range. Now, functions are special relations, so functions are a subset of all relations. Functions are when each element of the domain is paired with exactly one element of the range. So it's a predictable map from an input to an output. Think about a class of students. If I have two students with first name Riley, then if I'm not giving you any other clue of who I'm talking to, just by saying their name, you won't be able to figure it out. So therefore, Riley and whatever their last names are, that is not a function. But if there's only one Robert in the class, whenever I say Robert, you know I'm talking to that student whose last name, say, is Cooper. There are two ways that you could tell if a relation is more specifically a function. A, there are no repeats in the domain, so no repeated x-coordinates, the first numbers in the ordered pairs. You could also visually assess the situation using the vertical line test, VLT for short, which states that if a vertical line intersects a relation two or more times, then it is not a function. With the following blue graph, we could see that any vertical line that I would place over top of the graph at any one point is never going to intersect this graph at two or more locations, so this blue function is said to be, this blue relation is said to be a function. Now this rightward opening parabola fails the vertical line test actually in an infinite number of locations. Here's one where we hit two or more times, so then that means it is not a function. It fails VLT. And this one here also shows, but at least one time, if it fails, then the whole thing is said not to be a function. And the reason is because let's say this location right here is -1. So the ordered pair -1, do I want it to go here with, let's say, 2? Or do I want it to go here with, let's say, -2? Because it's not a predictable map, meaning when I say -1, you don't know what the output should be, 2 or -2, that's what voids it from being a function. So for the first graph, you would say, yes, it's a function because it passes VLT, and for the second example, you would say it's not a function because it fails VLT. In this next example, we are looking at a set of points graphed on a Cartesian coordinate plane. We want to state the domain and range of the graphed relation and then answer the question of whether it's a function or not. So in general, you want to understand that the x and y ordered pairs give you the domain and range respectively. When finding the domain, scan from left to right, reading the first values of the ordered pairs to give the following domain. So note, I started at -4, just taking the x-coordinate here. Then I went to -3, 0, 1, and 4. I'll do the same now for the range, scanning from bottom to top. And that produces -2, 0, 1, 2, and 3. An important note is that if you have repeated elements of either the domain or the range, only write them once. Let's say I had another ordered pair with an x-coordinate of -4, so maybe say here, then I would only write one copy of -4 because that will then be representative of all copies of it. So don't be redundant. In mathematics, we usually avoid that. Next, we want to explain whether this relation is a function. This is presented in roster notation, so it's a list of information separated by commas in braces, and in this case it's ordered pairs, so we're talking a relation. Now, in this case, I want to know that if I have repeats in the domain, then it is not a function. As you can see, we have two domain values that are identical of 9. That means that we don't have a function, and please note the following. Avoid the trap of thinking that if you have repeats in the range, that would void it as a function. It wouldn't. You could have repeats in the range and still have a function, like in the following, where I have a upward facing parabola. Notice it will pass the vertical line test at every place, so it's a predictable map from any given input to an output. However, there are repeats in the range because let's say 1 is over here and 1 is over here. So it's only repeats in the domain that void a relation from being a function. The next two concepts are very important, and you will always want to keep your eye out for identifying whether a function that you're working with is considered to be onto and one-to-one. So onto functions, all elements in the range are used. So think of onto as every range or dependent value that you have has a pairing. So that's basically like saying every female student has a date to the prom. So in this case, the technical math definition that will be useful in more challenging contexts is to state that a function f from the domain to the range is called onto if all elements in the domain B, there is an element in A such that when you input that value, domain value, into the function, it maps it onto a B value. So that's just basically saying that every female student in the range, that there's a male student such that based on social protocol that there is a match and they have all females in the range have dates. So let's take a look at an example and a non-example. In this example, we are looking at an onto function because all values in the range are paired with a domain value. So from negative infinity to positive infinity vertically, every value of y from the y-axis can be mapped to an x value in an ordered pair. Now this is a non-example because as you can see down here below the vertex of the parabola, there are no ordered pairs. Therefore, there are values of f of x, the dependent variable in this case, that are not paired with an x coordinate. And that is why it is not an onto function. Moving on to one-to-one functions, this is when every element in the range is paired with exactly one element in the domain D. So in this case, a function f from the domain A to range B is called one-to-one. This is a shorthand for it. If whenever you substitute an A into a function, it will equal a range value substituted into that same function. If that's true, then A must be the same as B. So in other words, no element of the range is the image of more than one element in A. And the analogy I like to use here is that no guy asked more than one girl to the prom. Because that would be an issue if one guy asked two different girls to the prom. So let's look at a couple visuals. On the left, we could see that this exponential decay function passes the vertical line test as well as the horizontal line test. That's another way to assess if you have a one-to-one function. And over here, this absolute value function, yes, it passes the vertical line test, but it fails the horizontal line test. So that's why it's a non-example for one-to-one functions. To get a better understanding of these concepts of functions, relations, onto and one-to-one functions, we will look at mapping diagrams. What they do is they take all the first elements of the ordered pairs and you write those values in the domain, writing repeats only once, and then you do the same thing for the dependent variable, and then you draw arrows to map the numbers together. The first one looks like the following. So the domain is 5, -2, and 3, and the range is 1, 4, -1, and they map accordingly. Based on some rule, the input domain value of 5 produces a 1. The input or independent number of -2 goes and is mapped to the dependent value of 4, and then -3 goes to -1. So this is an onto and one-to-one function. So as you can see, every element of R is used, so that makes it onto, and each element in R is only paired with exactly one element from the domain. Looking at the next example, the independent numbers are 2, 8, and 4 as the domain, and the dependent 0, 3, and 3 for the range. So I've placed those values in their proper location in the mapping diagram. 2 maps to 0, 8 maps to 3, and 4 maps to 3. Now, it's still a predictable map, so it's a relation that's more specifically known as a function, kind of like all squares are rectangles. Because if I say 2, you know it goes to 0. If I say 8, it goes to 3. If I say 4, it goes to 3. So it's kind of like the idea of having siblings or of different ages, or more specifically twins in a class. If I say 8, you know that I'm referring to someone with the last name of 3. Or if I say 4, it's referring to the same family person. So in this case, this is an onto function, but not a one-to-one function. It's onto because, again, all range values are used. There's no value over here without an arrow pointing to it from the domain. But it's not a one-to-one function because the 3 has more than one domain value pointing to it. In the last example, I could eye up in the roster notation that I have repeats in the domain. Therefore, this relation is not more specifically a function. It does not follow that extra special rule that you, for every output, you have one unique input. Let's see how that looks in a mapping diagram. The 5 maps to both a 4 and a 1, so it's like a guy trying to ask more than one girl to the prom. And then this means it's not a predictable map. So if I say 5, do I want the output of 4 or do I want the output of 1? It's still a relation. It's still a set of ordered pairs, but it's just not a predictable map, so it's not specifically a function. Now, please note in the previous example how I wrote this 3 only once, even though it occurred in 2 ordered pairs. In doing so, that allowed me to clearly see that this was not a one-to-one function because I have 2 arrows pointing to the same number. In review, functions on a graph, relations on a graph are functions if they pass the vertical line test, because that will ensure that there are no 2 outputs for any given input. When given a relation in roster notation, whenever you have repeats in the domain, that is not a function. So this is not an example. Instead, it would be like the first one here. That would be repeats in the domain, so it does not produce a function, fails the vertical line test. And remember, ignore any repeats in the range. That does not matter for determining if a relation is a function. On to functions, all elements of the range or of the y-axis are paired to an x value. So there is an ordered pair for each y value. In this case, we're missing this part of. And then when you want to check for one-to-one functions, you're assessing if it passes the vertical line test as well as the horizontal line test. So then you are basically saying that there's no repeats in the range and no repeats in the domain. Mapping diagrams are just to conceptually help you understand onto and one-to-one functions.